What's up, guys? I want to show you how to solve this question, this integration 1 plus x squared divided by 1 plus x to the power of 4. So first thing I want to do, I want to factor x squared from both sides. So it will be x to the power of -2 plus 1, and here it will be x to the power of -2 plus x squared, and then dx. Then these two cancel out. Then I will have x to the power of -2 plus 1 divided by x to the power of -2 plus x squared. In this case, I want to have the perfect square, so I add and subtract 2 here. So 2 and -2, so I can add and subtract, it will be the same. And then here I can write same thing in the numerator, and the denominator, this and this and this together will be x minus x to the power of -1 squared. Why? Because it's going to be x squared plus x to the power of -1 squared minus 2 times x to the power of -1. So that will be x squared plus x to the power of -2 minus 2. That is the proof. So instead of these 3 terms, I can write x minus x to the power of -1 squared plus 2. Then next step, I have a variable change. U will be, don't forget the dx, u will be x minus x to the power of -1, or you can write x minus 1 over x. Du will be 1 plus x to the power of -2 dx. As you see here, this one in the numerator is going to be the same thing. So I have du, in the denominator I have u squared plus 2. And this one will be the integration of this formula, as we know, is 1 over root 2 where's tan u divided by root 2 plus a constant number, let's call it c. And if I have variable change again, going back to the original one, u was x minus x to the power of -1 divided by root 2, and then we have plus c. That will be the final answer for this question.